Hey everyone, welcome back to the channel. If you've been diving deep into cloud and data security, today's question is going to be a good one. We're talking about something that often confuses a lot of people, row-level security in Azure Databricks. Now imagine this. You're working for a company that wants to make sure regional managers only see data for their regions. Simple enough, right? But then comes the question, how do we actually enforce that securely and without creating a nightmare of manual configurations? Let's look into the question first. Question, a company wants to implement row-level security on its customer transactions table in Azure Databricks to ensure that regional managers can only view data for their respective regions. They are considering using ABAC policies with governed tags instead of manual table-level row filters. Which of the following best explains why ABAC policies are preferred in this scenario? Options. ABAC policies require users to define filters individually on each table. ABAC policies prevent all users from seeing any data unless they are granted direct table-level permissions. ABAC policies replace dynamic views entirely, requiring that all logic embedded in Python or Scala scripts. ABAC policies allow centralized control of row filters across multiple tables and schemas. All right, so take a second and think about this. What's the key phrase in the question? Row-level security and governed tags. That's your clue right there. Now this one's really interesting because when people first start implementing security in Databricks, they often think about doing it manually, like adding filters to each table that say region equals east or region equals west, but that quickly becomes painful, especially when you've got dozens or even hundreds of tables. So let's break this down together. Option 1 says that ABAC policies require users to define filters individually on each table. That's actually the opposite of what ABAC does. The whole point of ABAC, or attribute-based access control, is that it centralizes control. You don't want to be managing filters manually all over the place. Option 2 says ABAC policies prevent all users from seeing any data unless they are granted direct table-level permissions. That sounds kind of scary, right? But nope, not how ABAC works. ABAC doesn't block everyone by default. It dynamically decides what a user can see based on attributes. Think of attributes like labels or tags, maybe the user's region, department, or role. Option 3 says ABAC policies replace dynamic views entirely, requiring that all logic be embedded in Python or Scala scripts. That doesn't sound right either. ABAC doesn't force you to rewrite logic in Python or Scala. In fact, it's meant to make things easier. It works seamlessly with your SQL queries, dashboards, and even notebooks. And finally, option 4, ABAC policies allow centralized control of row filters across multiple tables and schemas. Now that's the magic right there. Here's why this matters. With ABAC, you can set policies at a higher level, like saying anyone tagged as region equals east can only see rows tagged region equals east. You don't have to keep adding filters manually for each new table. It's all managed centrally, using governed tags that Databricks can evaluate automatically when someone queries the data. So what does this really mean for you? It means consistency, scalability, and peace of mind. You're not relying on dozens of developers remembering to apply the right filters. You're not creating custom UDFs or hard-coding logic into notebooks. Everything is governed from one place, which means if you need to make a change, say a new region or a role update, you just adjust the tags or policy definitions, and it applies everywhere. Hang on, because this part's super important. These ABAC policies aren't just about convenience. They also reduce. Since they can't be overridden by individual table owners, you're ensuring that access control rules stay consistent across the entire platform. That's a huge win for compliance and data governance. And as a bonus, ABAC is generally more efficient than user-defined functions that apply filters table by table. So you're not just making things safer, you're making them faster. So yeah, if you picked option 4, you nailed it. That's the power of ABAC. Centralized, consistent, and scalable row-level access that keeps your Databricks environment both secure and simple to manage. So continuing now to the second question on data security in Azure Databricks. A healthcare analytics team is preparing a dataset for AI model training. The data contains sensitive PII, names, phone numbers, and emails. The team wants to anonymize this data while keeping it useful for downstream analysis. And here are the options. Option 1, Mask sensitive fields partially. Generate synthetic replacements for names and emails using Faker, and hash customer identifiers for consistent joins across tables. Option 2, encrypt all PII and store the encrypted data in the same table without generating synthetic data to ensure maximum protection. Option 3, suppress all PII fields entirely without masking or synthetic data generation, allowing the AI models to run only on partial information. And option 4, use generalization to replace all birth dates with birth years and pseudonymization for identifiers, but leave emails and phone numbers in plain text for model convenience. All right, let's unpack this one, because this is a really practical real-world scenario. When you're working with healthcare data, you're balancing two big goals: protecting privacy and keeping data useful for machine learning. You can't just delete everything, but you also can't leave personal info lying around. So the smartest choice here is option 1. Why? Because it gives you the best of both worlds: privacy and utility. You start by partially masking sensitive fields. That means, for example, showing only the last 2 digits of a phone number, or maybe replacing part of an email address with symbols. It keeps the data structure intact but hides the personal detail. Next, using tools like Faker to generate synthetic data, that's a game changer. You can create realistic fake names and emails that look completely genuine, so your dataset behaves the same way as the original but without exposing real people. And then there's hashing identifiers. This step is critical. When you hash an ID, say a patient ID or customer ID, it turns into a consistent but irreversible string. So if the same patient appears in multiple tables, you can still join them together securely, but no one can trace it back to the real person. That's what makes option 1 both secure and practical for AI and analytics work. Now, option 2 might sound appealing at first, encrypting all PII, but here's the problem. Encryption is great for security at rest or in transit, but once it's encrypted, you can't use it directly for training or analytics without decrypting it. And that's risky and inefficient. Option 3, where you suppress all PII, is a little too extreme. Sure, you're protecting privacy, but you're also throwing away valuable information that might influence your model accuracy. Imagine trying to train a model on patient outcomes without any identifiers or demographic details. You lose context. And option 4, well, that's just asking for trouble. Leaving emails and phone numbers unmasked breaks compliance standards like GDPR and HIPAA. Even if your intentions are good, one exposed field can result in a serious data breach. So if you think about it, option 1 checks every box: privacy, compliance, and data utility. It's the kind of approach data engineers actually use in real Azure Databricks pipelines, especially when preparing data for large-scale AI projects. By combining masking, synthetic data, and hashing, you create a safe, realistic data set that's perfect for testing, modeling, and analytics. So to sum it up, anonymize smartly, not blindly. Protect personal data, but don't destroy its analytical value. Azure Databricks gives you the power to do both, and that's exactly what makes this question such an important one for anyone working in data science or cloud analytics. All right, so let's look into the third question. Imagine you're part of a data engineering team, and you have this financial transactions table. Pretty standard stuff, right? But here's the catch. Some columns are super sensitive, like SSNs and credit card numbers. The team's goal is to mask these columns based on user roles. So depending on who's querying the table, they might see full data, partially masked data, or maybe nothing at all. Now, here's the question. What's the correct way to implement this in Azure Databricks? Here are the options. Encrypt columns at rest and allow all users to query directly. Replace the table with dynamic views per user role to apply column masking. Use row-level filters only to protect sensitive columns. Define column masks as SQL UDFs managed via ABAC policies. Okay, hold on. Take a second to think about that. Some of these might seem tempting at first glance, but let's break it down together and see what actually works best. So the right choice here is to define column masks as SQL UDFs and manage them via ABAC policies. Hang on, because this part's super important. What that means is you're using SQL user-defined functions, or UDFs, to dynamically mask columns. And then ABAC, which stands for Attribute-Based Access Control, lets you define who gets to see what. Why is this so powerful? First off, UDFs allow you to mask sensitive data at the column level while keeping the table structure intact. You don't need to create a bunch of duplicate tables for different roles, which is a huge time saver. And ABAC policies centralize access control, so you can manage permissions all in one place instead of scattering logic across multiple scripts or views. Plus, you can even extend the masking logic using SQL, Python, or Scala if your requirements get more complex. Now, you might be wondering why the other options don't cut it. Let's talk about that. First, encrypting columns at rest sounds secure, right? Well, here's the catch. The data is safe while it's stored, but once someone queries the table, the sensitive info is visible, so it doesn't actually solve the problem of role-based masking. Next, we have replacing tables with dynamic views per role. This one seems clever, but think about maintenance. Every time you add a new user role, you'd have to create and maintain multiple views, which can get messy really fast. Not very scalable. Then there's row-level filters. These are great if you want to hide entire rows based on certain conditions, but they don't protect individual columns. Your sensitive SSN column could still be exposed even if the row is filtered partially. So, in short, by combining column masks via UDFs with ABAC policies, you get something that's scalable, maintainable, and centralized. It protects sensitive columns consistently, keeps things compliant with governance standards, and avoids a mess of duplicate tables or complicated filters. All right, to wrap this up, column-level security in Databricks isn't just a nice-to-have. It's essential if you're handling financial or personally identifiable data. Using UDF-based column masks with ABAC policies gives you the best of both worlds: secure, role-based access without making your data architecture a nightmare. So let's look into the fourth question. Imagine this. Your team is deploying dashboards and pipelines, and you want everything to automatically reference a specific database catalog defined in your bundle configuration. The goal is that any SQL queries or Lakehouse objects created by jobs should inherit this catalog context without anyone having to manually adjust things after deployment. Sounds like a dream, right? But the question is, which resource in Databricks asset bundles should you use to standardize this catalog mapping? Here are the options: the dashboard resource, the database catalog resource, the serving endpoint resource, declaring a cluster resource. Okay, take a second and think about it. Some of these might sound plausible at first glance, but let's break it down together and see what really works. The right choice here is the database catalog resource. Hang on, because this part's super important. Using the database catalog resource is how you standardize catalog-level configuration across your deployments. What this means is that when you define a database catalog in your bundle, all your dashboards, SQL pipelines, and other artifacts automatically associate with the correct catalog. No more manual adjustments or frantic last-minute fixes after deployment. Now, you might be wondering why this is such a big deal. Well, think about it. Without a database catalog resource, every time you deploy to a new environment, say dev, staging, or production, you'd have to manually update each dashboard or pipeline to point to the correct catalog. That's tedious, error-prone, and honestly, just asking for trouble. By defining database catalog in your bundle, all dependent resources inherit the right metadata routing automatically. It keeps everything consistent, scalable, and much easier to manage. Let's also look at why the other options don't quite cut it. First, the dashboard resource. It doesn't automatically apply catalog routing. Dashboards are great for visualization, but they won't enforce which catalog your SQL queries point to. Next, serving endpoints. These are all about compute and serving your data, not about metadata routing or catalog bindings. And finally, just declaring a cluster resource. This manages your compute environment, but it won't ensure that dashboards, pipelines, or queries inherit to the correct catalog. So what does this really mean for you? By using database catalog in your Databricks bundle, you get a centralized, reliable, and maintainable way to ensure that all your deployed artifacts are pointing to the right catalog. It's especially critical when working in multi-environment setups, because catalogs can vary between development, staging, and production. This approach not only prevents mistakes, but also aligns with best practices for governance and compliance. All right, to wrap this up, Catalog mapping might sound like a small detail, but it's one of those things that can make or break your deployment workflow. Using the database catalog resource ensures consistency, reduces errors, and saves a ton of time for your data engineering team. So next time you're setting up a Databricks asset bundle, remember, define your database catalog and let it do the heavy lifting for you. And that's it for today. If you found this helpful, don't forget to hit that like button, subscribe if you haven't already, and drop a comment below if you want me to cover more Databricks best practices. Thanks for watching, and I'll see you in the next one.